All right, I like this example a lot from Keller. This is a very, very funny example. Here we're talking about a student called Pat Stat Dude. All right, he's a student taking a statistics course, but he's not very fond of statistics, so he does not like to read anything about it. He does not practice, he does not do his assignment, etc. So he has a very his own strategy about the exams, which is pure luck. And we all know that this does not work. So let's prove it scientifically now for Mr. Pat that this will not work at all. Okay, so if Pat will take a quiz of 10 multiple choice questions, okay, and he answers simply by luck, and every question has 5 possible answers. Okay, here we go. It has 5 possible answers, and we know that only one is correct. So if we call x the number of correct answers, okay, so x is number of correct answers of, sorry, but I'm writing with my mouse, so it's not very effective, so bear with me. Correct answers. All right. Now, why this is important? Because now we can tell what would be P for us. So what is P? Right? What's P? According to the previous definitions, P is the probability of a success. And I'm calling the success is having a correct answer. Because only one question out of 5 is correct, that means P is equal to 0.2, right? So that's 0.2. And now I know that 1 minus P is 0.8. So what's the probability that Pat gets no answer correct? So meaning that this is P of 0, right? P of x equals 0. Now let's remember what's the binomial probability function is. Here we go, just to remember how to use it. So all what I have to do now is to substitute x here with 0, n with 10 because we have 10 questions, and p with 0.2 and 1 minus p with 0.8, and we're ready. So here we go. P of 0, it's 10 factorial over 0 factorial, 10 minus 0 factorial, 0.2 to the power 0 because it's p to the power x is 0 in this case, times 0.8 to the power 10 minus 0, which means 0.8 to the power 10. And we'll have an answer of 0.107. I strongly advise you guys to practice this, how to do that, especially the factorials and power here on your calculator so that you can get ready for the exam. All right. Second question, what's the probability that gets 2 answers? So we're talking here about x equal 2, right? 2 answers correct. So this is P of 2. All what we have to do is to plug, also substitute x with 2, and we will have this. So P of 2 will be 0.302. Okay, we will do more questions in later slides. Okay, sometimes we are interested not only to find the probability of a specific number of successes, so P of x, but rather we're interested to find what the probability that x will take a value less than or equal than a specific value, right? So here we're talking about a range of values. So this is here we're referring to P of x less or equal than this specific value. So what do we call that? We call that a cumulative probability, obviously. How to find it? It's exactly, we will follow the same formula that we learned, but all what we have to do, because this is cumulative probability, so we will end up finding more than one probability and then add them up and maybe subtract them from one or not. We'll see in which context we are asking this question. So in this example, the question is, what's the probability that Pat will fail? Okay. So before we proceed by calculating that, considering the strategy followed by Mr. Pat, what do you think about the probability that he will fail? I would say that it's a very, very high probability. So let's find it, right? So we're talking about probability that he will fail. And according to that instructor where Pat is enrolled, a student will fail if he scores less than 50%. So less than 5 questions out of 10. So in other words, the probability of fail is P of X less than 5, right? Which is what? So all what we have to do is to count the number of events that will satisfy that. So which is P of 0 plus P of 1 plus P of 2 plus P of 3 plus P of 4. Now we have to find each one of these. We already have found previously P of 0 and P of 2. So what we need now is P of 1, 3, and 4. Remember how we did it before. All what we do is to substitute X with the value that we are interested in. Here it's 1. So it's n factorial 10 factorial over X factorial. So here it's 1, etc. And we get 0.268. We do the same for P of 3 and the same for P of 4. And now what we have to do, because the question was probability of failing, meaning that we need all these. So we sum up this one and this one and this one and this and that. And the final answer would be 0.967. So what's this? Pat will have a chance of 96.7% that he will fail. And this is obvious because his strategy does not work at all whenever we have multiple choice with 5 questions. Okay, so let's not be similar to this Pat dude, and let's learn better than him. All right. Okay, so in the previous question, what we did, we found a cumulative probability, right? Because cumulative probabilities sometimes tend to include very large number of calculations, which will be very much time consuming, some tables were prepared. And in our textbook, we have a table numbered 1 in Appendix B that give us cumulative probabilities depending on the number of trials and on what is P. All right, so we have different tables for the different combinations of N and P. So let's see the table that that we can use in our case, because in our case we know that we have N trials, right? So here we go, and these are the different values of P. In our case, it's 0.2. And remember the question was P of X less or equal less than 4, which means it's 0 or 1 or 2 or 3 or 4, right? So here we go. It was 4. So what we do is we look into the intersection between the column that has P 0.2 and the row where we have the value 4. Okay, and this we get 0.967, which is the same value that we got in the previous example. So you could use either the table, here we go, or you can simply do the calculations. All right. Finally, when we have a variable that has binomial distribution, we can find the mean as being n times p, where n is the number of trials times the probability of success. We can find the variance, which is n times p times 1 minus p. And we can find the standard deviation, of course, which is the square root of the variance. So that's very straightforward. Let's do an example to illustrate these calculations. Again, this is a very funny example. This professor is not a lucky professor at all, because all his students are similar to Mr. Pat, okay, which is obviously a nightmare for him. So what do you think would be the mean grade for all the students taking the same quiz that has 10 questions? So what we need to do is to apply this formula for the mean, right? Where n is the number of trials, 10, and p is 0.2. So the average will be 2 over 10. Of course, it's a very low average, but this is very expected knowing that everyone follows the same strategy as Mr. Pat. All right. And the standard deviation, we get it by simply applying the formula where n is 10, p is 0.2, and 1 minus p is 0.8, and we square root the whole thing, and it will be 1.26. All right, so this completes our segment about binomial distribution. I hope that everything was clear for you.